or 2? 4. Okay, this is like the practice. This one? Okay. So this is it really matters what kind of graph you have, and I can see. So in 4 they give you position, in 5 they give you velocity. So you really have to think about like what you're looking at. So this is position, and I know it's not like they didn't really give me labels, but I'm just going to think about it this way. So this is just position. So like you start here. If I could talk through what happened here, this person went forward for a second, they stopped for a second, they came backwards. So right now they're back where they started. Now they're behind where they started, and then they just like chill out for 2 seconds, and then they go backwards. Does that make sense? Like talking through that. So left is negative and right is positive. So when am I going to the left? You want there to be a negative slope. So we are going to the left from 2 to 3, and from 5 to 6, and then you'll very often be asked to justify it too. I'm surprised you're not asked to here. But if you had to justify it, you would say because f prime t is less than 0, or the slope of f is less than 0. Those are the exact same state. So left is like we're moving backwards. What is p moving to the right? So you would want a positive slope. So the only time is right here from 0 to 1. And again, you could say f prime of t is greater than 0, or slope of f is greater than 0. Yes. So what is the velocity at 0? I don't know what I'm talking about. It's 0, so you're not technically moving to the right. You're in motion. When is p at rest? So our position is not changing between 2 and 3, or between 3 and 5. So here you would say the slope of, if you had to justify it, which you will, the slope of f is 0, or f prime of t is 0. And then graph the particle's velocity where it's defined. This is a little tougher. You're going to have, so there's like 1, 2, 3, there's like 5 sections. If you want to look at the slope of each section, so that right there, your velocity is 2, because you're going up 2 over 1. So I'm going to put a bar there to represent that. This is my velocity. So I'm drawing the slope of the position. The slope of this little section here is 2, so that means my velocity is 2. The slope of this is 0, so my velocity is 0. And I'm putting open circles here because of the corner thing. You can't take the derivative at a corner. So those two don't have like the closed bracket. My next section from 2 to 3, I go down 4 over 1. So my slope will be negative 4 there. And then I go back to 0 from 3 to 5. And that looks like negative 2. For that last section. So you get like this step function. Other questions on this one? What else? Let's go to 4-3. something's increasing or decreasing, check the sign of the derivative. If the derivative is positive, it means we have a positive slope, and the original graph is increasing. If it's negative, that means we have a negative slope on the original graph, so therefore it's decreasing. So height is increasing. If what they're kind of trying to do here is just show you like different examples. So that would be increasing if height prime is greater than zero. Like we're pretending height is some equation. How do we know if height is increasing? We would take the derivative and look for where is this derivative above zero. So velocity would be decreasing. This one I can say if acceleration is negative, because the derivative of velocity is acceleration, right? If you put like velocity derivative, that's still correct. That's the way to get. IQ is increasing if, so this would be like IQ prime greater than zero. And LA, we're gonna get through. LA was scary because there was emojis in that. But we're gonna get through it. We're gonna go that guy prime is less than zero. He's crooked. That's true. Get your calculator out. Yeah. See if we still remember how to use that thing. Yeah, but if it's like getting back like this, way too far away. That's not stable. That's like lost luggage.
It's like other.
Okay. Hey, this is number the next part of the notes. Number 3, number 1. I don't know. This is the next thing. Yeah. They want to know. I want to know, is this function increasing or decreasing when x equals 3? So we learned how to take the derivative, but on a lot of the AP tests you get your calculator. So I just want to like remind you how to. And plugging 3 with that in my hand is absurd. So I want to remind you how to do it with the calculator. So go to your main screen. Then I want calc for calculate, D for differentiate. Type in your 5 to the sine of x. If I hit enter now, what's going to happen? It's going to be sad. It's going to give you an error because what do I still have to tell it? Before that, I got to do the comma x. Comma x. That's telling me like what variable I'm working with. So if I say enter now, it would give me the derivative in general. If I do that again, but now I put that vertical bar and I type x equals 3. It gives me that, which is still pretty useless to me to know how to get to a decimal. I then enter. Now I can tell if the original function is increasing or decreasing. If we're negative, which means the original function is decreasing when x equals 3. So just two things there. We're like reminding that the negative derivative means decreasing, and reminding how to do it on ourselves. Okay. Okay. We got into a little bit of this yesterday. But just make sure you know like, what level you're at before you start labeling things. So if f of x is bunnies, this is a really cute class. We got emojis, bunnies. Then what would be the label on prime? Bunnies per year. Because it has to be a velocity. But then they'll often do this. Trying to make sure you're paying you want to call it. But now they're telling me, let's pretend f of x is bunnies per year. So they're starting us off with the velocity being like the original. So what will the label now be on that prime? Bunnies per year squared. Bunnies per year per year. Okay. Rate of change from a table. This is like an algebra 1 problem. Not totally, but it's p prime, so like we're doing a derivatives calculus, right? But all this is if these are the only 4 points we know, and I want to estimate the slope at 15. You just take the two closest ones that you have. So I'm going to do 10 and 20, and just do like y2 minus y1. 150 minus 120 over x2 minus x1. So, 30 over 10. I'm not quite sure I can do that accurately, so I'm just going to leave it. People per year. What do you think it is? Don't screw it up. Okay, p prime of 20. Hey. P prime of 20, you have 3 choices. You can find the slope between those two. There's 3 legitimate answers. You can do those two, or you can do those two. So you can go, I'm not going to do all of them. You're going to fair, right? I'm not going to show you how to find 3 slopes. Jason, yes, you want to? That's all I got. Which one would you like me to do? I'm getting nervous again because now I got 80 divided by 20. What that is. So I'm just going to say people per year. Why is he 4 about this? That's it. I don't know. I'm just making stuff up.
My brother's like gluten free because he doesn't like the solution.
Bro.
I don't know. I know.
No, I'm talking about
Oh.
I know.
My difference in your curve?
Yes.
Okay, yeah, no, I know.
I'm just clarifying.
Yeah, I imagine. We
Get out of the last time. That?
Yeah, you're getting fired.
How do you know?
Well,
Yeah.
doesn't hurt here. Doesn't even work here. Look at why you're laughing. This is a serious matter.
This is here.
I know where you were.
I know where you were.
Okay.
If you blew up my store, your store would go down with it.
They got to report all that to the office.
That's fine.
Yeah.
You're gonna say repetitive.
Okay.
Your calculus in labs?
That was actually. Yes. I just now got my exam. As soon as I invented
Yeah. Congratulations.
You invented paper?
That's where you look for check.
No, but I applied to Zoom.
So now you know worst case you're in.
Okay.
That's good. That's like, I don't know, right?
I mean, it's. maybe I'll make